Hello, everyone. In our previous lessons, we explored the principles of soybean counting. Today, we will apply those principles using machine vision software in this practical experiment. Let's now dive into the step-by-step operation for soybean counting. First, open the MV Viewer software to acquire images. Open the MV Viewer software and connect the camera. Click the Start Acquisition button. The live feed from the camera will appear on screen. Adjust the aperture and focus dials to obtain a clear image. Once the clear image is captured, close the MV Viewer software. Open Kimage software to begin the soybean counting operation. Open Kimage. Create a new project named Soybean Counting. The software will automatically redirect to the main project interface. A default empty tool group is created. Rename this tool group to Counting. Double-click to open the Counting tool group. Add the first PLC control tool. Double-click to open its parameters and enable the homing setting. Rename the PLC control tool as Homing. Add a second PLC control tool. Click the Execute button next to the homing tool, the first PLC tool, to return the motion platform to its 0 position. Each new project requires homing. Add Light Source Control tool and Camera tool. Run the Camera tool and observe that the soybeans may not yet be visible. Use the joystick to move the motion platform while clicking the Camera tool's Run button repeatedly to adjust the position until all soybeans are within the camera's field of view. Once the position is adjusted, record the current coordinates. Double-click to open the parameter window of PLC Control tool, and in the Axis Position section, copy the X and Y axis values into the motion settings. Click Execute. Double-click to open the parameter interface of Light Source Control tool and adjust the backlight brightness until the contour of the soybeans appears sharp. Double-click the Camera tool parameters under Image Settings. Increase the camera's exposure value. Click Execute. Add the first image processing tool. Double-click to open the parameters. And set the recognition mode to color to grayscale. Click Execute. The soybean image will appear in grayscale. Add a second image processing tool. Double-click to open the parameters and set the recognition mode to dilation. And adjust the mask width and mask height. Click Execute. At this point, the parameters of the camera tool need to be increased. Open the parameter interface of the camera tool and adjust the exposure value. Click the Execute button next to the tool. If soybean adhesion persists, continue fine-tuning the mask width and height in the image processing tool. Click Execute. There is no adhesion between soybeans. Proceed by adding the blob analysis tool. Click the Execute button on the tool's right side. No soybean count is detected initially. Double-click to open the blob analysis tool's parameter interface. Click Register Image. Then drag the detection area box in the image display window to fully enclose all soybeans. Note: ensure the area option is checked. Click Execute. Again, the system will now accurately detect and count all soybeans. In the Blob Analysis Tool's parameter interface, select Blob Count from the Output Parameters drop-down menu and drag it to the display window. This will visualize the soybean count in the image view. Now, let's manually verify the counting accuracy. The automated count matches our visual confirmation. We can also double-click the blob count in the window to modify font size, color, or text content. Everyone, these complete the operational procedures for the soybean counting experiment. Quite simple, isn't it? To reinforce today's lesson, please practice these steps after class. Thank you all for listening, and see you in the next class.